Okay, Pre-Calc, today we are going to talk about arithmetic sequences. So an arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. And the common difference is that numerical difference between any two terms, and we're going to call it D. So let's look at our examples. Our first one, we've got 29, 37, 45, 53, 61, and so on. What does D equal? D equals 8. If you take 37 minus 29, you get 8. 45 minus 37, you get 8. 53 minus 45, you get 8. So for number 2, we've got -7, -10, -13, -16, -19. So if we take -10 minus -7, that gives us -3, which is our D for this one. And number 3, we have 25, 11, -3, -17. So if we take 11 minus 25, we get -14, which is D for number 3. And number 4, if we take 7 minus -12, we get 19. So that is D for this one. Oh, and then it asks you for the next 4 terms. I didn't even see that. All right, well, let's do that quickly. The next 4 terms for number 1 would be 69, 77, 85, 93. Here, for number 2 would be -22, -25, -28, and -31. Number 3 would be -45, because I didn't write the -31, -45, what is that? -59, -73, and -87. And here we got 83, 102, 121, and 140. All right, let's look at the next part. The formula for an arithmetic sequence is AN equals D times n minus 1 plus A1. Okay, where A1 is the first term and D is the common difference. So now, if you know you have an arithmetic sequence, what we did in the last video was just sequences in general. Some of those sequences that we were finding rules for were arithmetic, but some of them weren't. Some of them were other kinds. So now we're only talking about sequences that have a common difference, that are arithmetic, that you're either adding or subtracting something to get the next term. So let's look at number 5. It says write a rule for each sequence, then find the indicated term. So here is our what we're given, and we're looking for A32. All right, but first we have to write a rule. We're going to use this. We have to know A1 and we have to know D. Well, A1 is 7, and D, what's the difference between each of these? That is 6. So we're going to use those and substitute it into this equation, and we're going to get AN equals D times n minus 1 plus A1. And now we're going to simplify this because this is not simplified. So we're going to distribute the 6 and then combine like terms. And we have that an equals 6n plus 1. That is the answer to the first question where it says write a rule for each sequence. Now to find A32, all we have to do, we're going to use this, and we're just going to substitute in 32 for n. So we do 6 times 32 plus 1, and we get 193. Okay, and that's our answer. That's A32. That's what we're doing here. So let's look at number 6. We've got 4, -7, -18, -29, and -40. So A1 equals 4, and D equals -7 minus 4, which is -11. So our rule is D times n minus 1 plus A1. And we're going to simplify. And we get our rule to be -11n plus 15. There's our rule. And then we're looking for A, 24? A24. So we're going to substitute 24 in for A, and you should get -249. All right, let's look at number 7. Remember that as you're going along, if you feel like you understand this, you can skip some of the examples. I'm going to do all of them, but you do not have to. These are your notes. So we're going to say A1 equals -23, D equals -19 minus -23, which equals 4. And then we're going to use our equation and say D times n minus 1 plus A1 and distribute. And we get AN equals 4n minus 27. And to find the indicated term here, which is A45, we're going to say 4 times 45 minus 27, and we get 153. And one more, number 8, -3, -5.5, -8, -10.5, -13. All right, no, that was wrong. A1 equals -3, and D equals -5.5 minus -3, which equals -2.5. So for our rule, we're going to say -2.5 times n minus 1 plus A1, and we're going to distribute. And we're going to get AN equals -2.5n minus 0.5, or 0.5. And to find our indicated term, A39, we're going to say -2.5 times 39 minus 0.5, and you should get -98. All right, those are arithmetic sequences. So now, that's if you know what A1 is and what D is. Now we're going to look at some examples where you might not know both of those. So I'm going to put the formula up here at the top, just so that we have it. All right, and let's look at number 9. It says use the information given to find the indicated value. So we have A1 equals 29, and we have D equals 7, and we need to find A36. Now you could go through, just like we did in the last problems, and actually find the rule and then find A36, but you actually don't have to do that. Because we're not looking for the rule, we're only looking for A36, we can just go right ahead and substitute 36 in for N, because that's what we're looking for, and then 29 in for A1, and 7 in for D. So we can say A36 equals 7 times 36 minus 1, so that's what's going in for N, plus 29. So we've got 7 times 35 plus 29, and we can know that A36 equals 274. All right, so you see how that's different from what it was asking us in the problems right before? It actually asked us for the rule and then find a term. Here, all we're looking for is the term, so we don't need to necessarily find the rule. You can if you want, but you don't have to. All right, let's look at number 10. If A22 equals negative 156 and D equals negative 9, find A1. So now let's look at our equation up here. We know D, and we know an N right here, 22, and we know, well, we know an N, 22, and we know an AN. N is 22, AN is negative 156. This is what we're looking for. So that's going to be our unknown. So we're going to say negative 156 equals D times 22 minus 1 plus A1. Do you understand that, where those numbers are coming from? We're using N equals 22 and then A22 as this, because that's what we were given. Now you can just solve this for A1, and you should get A1 equals 33 if you solve this. Okay, let's look at number 11. Again, I'll put this up here so we can see what we know and what we're looking for. All right, number 11, we have A1 equals 11, and we have A25 equals 107, and we're going to find D. So now we know this, and this, and this, and we're going to solve for this. So substitute in what we know. 107 equals D times 25 minus 1. This is the N plus A1. And now you can solve for D. So you get 107 equals 24D plus 11. So 96 equals 24D, and D equals 4. And that's our answer. So in number 9, we looked for AN. That's what we didn't know. We knew D, N, and A1. In number 10, we knew AN, we knew D, and we knew N, and we looked for A1. And here in number 11, we knew AN, N, and A1, and we solved for D. So let's see what number 12 is going to bring us. All right, number 12, we have A1 equals 5, and A18 equals negative 199, and we need to find A13. So we're going to have to do 2 steps for this one. We're first going to look at what we're given here and what do we not know in this equation. We know A1, we know AN, we know N, we don't know D. So we're first going to find D, and we're going to say AN, which is negative 199, equals D times N minus 1. Here's our N, here's our AN, plus A1. And we're going to solve this to find D. So we get negative 199 equals 17D plus 5. And we get negative 204 equals 17D, and D equals negative 12. Now we know everything up there, and this is like a problem like number 9. Okay, and we will say we're going to try to find A13 equals D times N minus 1 plus A1. And then just go ahead and solve this for A13, and you should get negative 139. All right, so you see for that one, we had to do 2 steps. Let's look at number 13. Number 13, we know AN equals negative 76. A1 equals negative 21, and D equals negative 5. Find N. So looking at our equation, okay, in this equation we have 1, 2, 3, 4 unknowns. We're given 3 of them, so let's find the other one that we don't know. So we're going to say negative 76 equals negative 5 times N minus 1 plus negative 21. And we're going to solve for N. All right, so I am going to distribute this 5, this negative 5. And then I'm going to get negative 60 equals negative 5N, and N equals 12. So what that is telling us is negative 76 is the 12th term of this sequence. And let's do one more. Number 14, we have AN equals 310, A1 equals negative 15, and D equals 13. This is the same kind that we just did. So we're going to say we want to know, we're finding N. So we want to know what term is 310 in this sequence. So we say 310 equals D times N minus 1 plus A1, which is negative 15. So go ahead and solve this, and you should get N equals 26 when you solve all that. So 310 is the 26th term. All right, so let's go on to the next part, explicit versus recursive formulas. Remember how we talked about yesterday that, or in the last video, that in some sequences you can write both an explicit and a recursive? That formula that I gave you for arithmetic sequence gives you an explicit formula. So that's what you're going to use. This right here gives you an explicit formula. When we find this formula, it's in terms of N. And a recursive would be what you're starting. You're going to define your first term and then write a rule using the term before it. So for an arithmetic, the explicit, we're going to use this. So in this one, let's see, A1 equals negative 19, and D equals negative 17 minus negative 19, which is 2. So to find the explicit here, we're going to say an equals 2 times n minus 1 plus negative 19, and then go ahead and simplify this and get an equals 2n minus 21. Then for a recursive, all we're going to do is define the first term. So we're going to say a1 equals negative 19, and then we're going to say an equals an minus 1, which is the term right before it, plus d, whatever d is, for n greater than or equal to 2. Remember that this rule only works for the second term on up. We have to define the first term. So this is easy enough. So let's look at number 14. We got 37, 31, 25, 19, 13. Okay, A1 equals 37, D equals 6, or negative 6, I'm sorry, negative 6. And so our explicit is going to be an equals d times n minus 1 plus a1, and go ahead and simplify this, and you get an equals negative 6n plus 43. There's your explicit. Your recursive, we're going to define a1 as 37, and then say an equals an minus 1 plus d, or in this case, minus 6. You can say plus negative 6 or minus 6 for n greater than or equal to 2. All right, now we get 3 pages for these notes. This was review from things that we've done last year. So arithmetic means are the terms between any two non-consecutive terms in an arithmetic sequence. Okay, for example, if you look underneath, given the sequence 2, 8, 14, 20, 26, 32, the arithmetic means between 8 and 32, 8 and 32 are 14, 20, and 26. Those are the arithmetic means. All right, let's look at some examples. Number 17. Find the indicated arithmetic means for each set of non-consecutive terms. So we got 17, 50, and 118. And we're looking for, oh, I did that wrong. What in the world? 50 and 18, and we're looking for 3 means. What that means is we have a 50 and we have an 18, and there's 3 terms between them. We need to know, in order to know what those are, we need to know what D is, because if we know what D is, then we're just going to add it to 50 and then add it to that and then add it to that to fill them in. So we can say A1 equals 50, A 1, 2, 3, 4, 5 equals 118. Okay, we don't know that 50 is the first term and 118 is the 5th term, but we can just pretend like it is, and that's still going to give us what D is. So now put those into our equation and say an equals D times n minus 1 plus a1. Okay, this is n, this is an, and D is what we don't know. So we're going to go ahead and solve this for D. And we're going to get D equals 17. So then we can go ahead and fill in our arithmetic means. We can just say 50 plus 17 is 67, and 67 plus 17 is 84, and 84 plus 17 is 101. And then if you wanted to check it, you could say 101 plus 17 equals 118. So we did it right. And here are our 3 arithmetic means. All right, let's look at number 18. We've got -16 and -58, and we want 5 means. All right, so we're going to set it up. We got -16, and we want 1, 2, 3, 4, 5, and then we need -58 right there. So we're going to say A1 equals -16, and 1, 2, 3, 4, 5, 6, 7. A7 equals -58. So we're going to substitute that into our equation and say AN, when n equals 7, is -58 equals D times 7 minus 1 plus A1. Look what I did over here. I distributed the D, but I don't need to distribute the D. I can just say -58 equals 6D minus 16. That was weird. And then we get D equals -7. So we can go ahead and fill those in and say -16 plus -7 is -23, plus -7 is -30, plus -7 is -37, plus -7 is -44, plus -7 is -51, and we can check it, plus -7 is -58. So we're done. All right, let's look at number 19. These are kind of fun. We've got between 17 and 5, we're looking for 7 means. 1, 2, 3, 4, 5, 6, 7. And we can say A1 equals 17 and A what equals 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. A9 equals 5. So we're going to put those into our equation and say AN is 5 equals D times n minus 1 plus A1. So we have 5 equals 8D plus 17. And we get a fraction. We have D equals -3/2, or -1.5. So we're going to do that. 17 minus 3/2 is 31/2. Minus 3/2 is 14. Minus 3/2 is 25/2, and then 11, and then 19/2, 8, and 13/2. And if you subtract 3/2 from that, you get 10/2, which is 5. So those are our means for this one. And our last one, number 20, we've got 2.265, and you're going to have 4 means. 1, 2, 3, 4. They're going to be a lot of, oh, it's not a point. It's a, let me do that over. It's a comma. So 2,265 and 3,540. This is A1. This is A what? 1, 2, 3, 4, 5, 6. A6. So we're going to say A6 equals D times 6 minus 1 plus A1. And when you do that, you're going to get D equals 261. So filling these in, you should get 2526, 2787, 3048, and 3309. And that's the end of that. So now we got a couple applications here. Okay, number 21. a theater has 35 seats in the first row, 39 seats in the second, 43 seats in the third, etc. Write both an explicit and recursive formula to find the number of seats in the nth row. So what do we know? A1 is 35. There's 35 seats in the first row. And we know D equals, well, we know a couple things. We know A2 equals 39 and A3 equals 43. So we can just look at this to find that D equals 4. So we can write our explicit with our formula, AN equals D times n minus 1 plus A1. And then go ahead and simplify it and get AN equals 4n plus 31. That is our explicit. And our recursive is going to be A1 equals 35, AN equals AN minus 1 plus D for n greater than or equal to 2. And that is our recursive right there. All right, that was pretty simple. Now let's look at 22. Brian weighed himself at the end of each week into his new diet. The table to the left shows his weight at the end of each week for the first 3 weeks of his diet. Write an explicit rule to find his weight in n weeks into his diet, then find his weight after 16 weeks. Same thing. Okay, let's write what we know. A1 is 256.3. And from looking at that chart, we can find D is negative 1.7 just by subtracting. That means he's losing 1.7 pounds each week. So to find our explicit, we're going to say AN equals D times n minus 1 plus A1. And then go ahead and simplify this, and you should get AN equals negative 1.7n plus 258. There's your explicit. Your recursive is A1 equals, is that what it asked you to do? Oh no, then find his weight. Didn't ask you for that. It asked you to find his weight after 16 weeks. So we're looking for A16. So we're just going to use this and substitute 16 in, and you will get A16 equals 230.8 pounds. Okay. And the last one, number 23. On Anna's first birthday, her grandma gave her a check to open a college savings account. Her grandma continued to send checks on her birthday, each at the same amount. At 7 years old, Anna's grandma had given her a total of $610. At 18 years old, she had given her a total of $1,270. How much money did Anna's grandma give her on her first birthday? Ooh, this one is tricky. We don't know A1. That's what we're looking for. What do we know? We know A7 equals 610 and A18 equals 1,270. So there's a lot of ways that you can do this, but what I'm going to do is I'm going to just call this my A1 and this A12. Whoops, I wrote that backwards. Just to find what D is, because if I can find D, then I can go back and find A1. Because in our formula here, this is what I'm looking for, but I don't know this and I don't know this from what is given. So I have to find those out. So I'm just going to call this A1 and A12. And in doing that, I'm going to get AN equals, oh no, that's not what I want to do. I'm going to get AN equals D times n minus 1 plus A1. And I'm going to solve for D. right here. So I get this, and I'm going to get D equals 60. So now I just changed these to 1 and 12 just to find what D is. So now I'm going to go back and I'm going to say D equals 60 and a 7 equals 610 and a 18 equals 1,270. And I am looking for a 1. Now I could just take my D and start right here and just start subtracting 60s from there to get back to 1. Or I can just take these things and put them back in here to find what A1 is. I can say, and I only need to use one of these. I can use whichever one I want. I'm going to use A7. I'm going to say AN equals D times n minus 1 plus A1. So I'll get 610 equals 60 times 6. And so I get 610 minus 360 equals A1. And I'm going to make, I did this different than in my notes, so I'm going to make sure I'm doing it right. $250. You get A1 equals $250. And that is the answer. All right, those are the end of the notes for this section.